If I heated something up and it changed color, that it was carbon and oxygen, some chemical, and I found out there was 5 grams of calcium in there, empirical formula for the fuel that you used. So today's lesson will be a focus on gravimetric analysis. So in chemistry, we have lots of different types of analysis methods. And one of the most important ones is this gravimetric analysis. You can hear it from the word, it's gravimetric, so it's sort of relating to gravity. So what that means is that this will probably have something to do with weight or mass. Gravimetric analysis usually has a focus on getting a mass quantity out. So in terms of chemical analysis as a whole, we want to sort of determine the composition of a sample, and that's what we call chemical analysis. So when we are looking to figure out what's inside this substance, that's when we talk about chemical analysis. In chemistry, we can either have a quantitative analysis or a qualitative analysis. Qualitative, it's sort of the first part is relating to quality. This particular slide is good or this particular slide is bad. They're not numerical. Qualities are something that you can't place a value on. Qualitative analysis, you don't assign values to what you get out. For instance, if I heated something up and it changed color, the color change maybe went from red to blue. Now, I can't assign a number to that change. It would be a qualitative assessment or a qualitative observation. It changed from red to blue. Okay, that's qualitative because there's no number associated with that. So qualitative analysis involves simply determining what's in the sample. Okay, so if I had a chemical and I realized that it was carbon and oxygen, that's qualitative because there's no number assigned to it. We just know that there's carbon in there and there's oxygen in there. See, so there are no numerical values assigned. Quantitative sort of sounds like quantity, and quantities are numbers. I can have 3 apples or I can have 20 apples. They're quantities of apples. Quantitative analysis, what we're looking for is how much of a particular chemical is in a sample. Okay, so if I took a beaker of some chemical and I found out there was 5 grams of calcium in there, then that would be a quantitative measure or a quantitative analysis of that sample. Quantitative, quantity, numbers. Qualitative is like quality, and so there are no numbers. In quantitative analysis, we can actually split that into 2 more subgroups. Within quantitative analysis, we have gravimetric analysis and volumetric analysis. And I'll go through what they are in a second, but remember that so there's quantitative and qualitative, and then inside quantitative, there's 2 more, which is gravimetric and volumetric. So gravimetric analysis is the measurement of mass. If we took a sample and weighed it out, or performed a chemical reaction and weighed the products, that would be a gravimetric analysis. Whereas volumetric analysis is the measure of solution volumes. So for instance, if I had an acid and I mixed it with a base and I knew what the volumes of acids and bases were, and then I got something out, that would be a volumetric analysis. And you can have sort of mixtures of the two where you use a volumetric analysis to sort of work out a mass. Volumetric analysis is simply looking at volumes of solution, so salt waters or any sort of solution that you can think of. Yeah, so that's the major difference. Gravimetric, mass, volumetric, volume. Now we look at gravimetric analysis, and this involves accurately, here's a key word, accurately measuring the masses of a particular substance. So we use this a lot in different industries, particularly the pharmaceutical industry, the food industry, and the mining industry. And you can see here that each of these really needs to know how much mass it is. For instance, if you're a miner and you promised some company 2,000 tons of iron and you only could produce 1,000, then they're not going to be very happy. And in the pharmaceutical industry, this is even more important because if your tablet says 200 grams of drug X and it's actually like 600 grams, then you've probably inadvertently killed someone if you didn't get this right. In gravimetric analysis is super important in these industries for economic and even safety reasons. What will happen most of the time in gravimetric analysis for chemistry is that you'll make a precipitate or something, you'll mix 2 solutions and get a precipitate out, and then you'll weigh the precipitate. That's one common example. Or you'd take the measurement of combustion byproducts and then take those and try and develop a empirical formula for the fuel that you use. For instance, if I took a piece of wood and I lit it on fire, I weighed it first and then lit it on fire, then took out all of the byproducts and weighed them, I could actually develop an equation or a formula for the chemical composition of wood based on my byproducts of combustion. So those are the 2 typical ones that you'll see: weighing precipitates and developing empirical formulas for complex fuels using combustion. So that concludes today's lesson on gravimetric analysis. We looked at what gravimetric analysis is and what chemical analysis is as a whole, and what are the different subgroups of chemical analysis. So move on to the question segment now and see if we can answer some questions.